All right, here we are, day 2 of me being gone. So you're going to be watching your second video of the week, and it's going to be on the Pythagorean Theorem. You'll notice up at the top it says 8-2. Yes, I know that. You're going to be doing actually 8-1 tomorrow in class with me, so we'll get back on track, but actually it helps us out to do 8-2 first. 8-2, we're going to be talking about the Pythagorean Theorem, review topic from Algebra 1, as well as for, other middle school classes that you've probably seen it. We'll talk about using the converse of it, and as well as take a look at some Pythagorean triples. All right, Pythagorean Theorem, a squared plus b squared is equal to c squared. That formula should look very familiar to you. We've even used it a couple times already in this class this year. Now the A and the B, those stand for the two legs of your right triangle. So it's the two sides that make up the right angle. And C is always going to be your hypotenuse. Now when you look at your hypotenuse is always going to be the longest side of a right triangle. And it's always going to be opposite of that 90-degree angle. People get confused with that all the time, but your longest side should always be that value of C, which is your hypotenuse. So what we're going to do with our formula now is we're going to find missing sides, whether it's the legs or the hypotenuse. And you're going to find that I'm going to be keeping our answers as exact answers. So we're going to leave them in that square root form. That's why we did the whole radical review yesterday. So here's an example. We have 8, 12, and x. And what we're trying to do here is solve for x. And I see that it's a right triangle. Well, with the right triangle here, my x is the hypotenuse. So that's going to be our value of c. My a and my b are going to be the 8 and the 12. It does not matter where the 8 goes or where the 12 goes, as long as they are your a and your b. All right, so we're going to go ahead and we're going to solve this out. So if we take 8 squared, which is 64, and we take 12 squared, which is 144, and then we add those two together, we're going to end up with, well, that equals x squared. So I'm going to get 208 is equal to x squared. The fact that this is x squared right here, now we're going to be solving. And to get rid of that square, I can take the square root of both sides. This right here would give me x is equal to plus or minus the square root of 208. Now, the one thing with dealing with a right triangle here is that you cannot have a negative length. So the negative square root is not going to be associated with this. Why is it plus or minus here? For example, let's say you had x squared is equal to 36. Well, 6 squared is 36, as well as negative 6 squared is 36. So you have two possible answers when you're working with x being squared. That's why when we factor things out, oftentimes we have two solutions. All right, so then going ahead here and trying to simplify and break down the square root of 208. We're going to leave it as an exact answer. And I can break up 208. I can take the square root of 16 and the square root of 13. Square root of 16 is 4. And I could not go any further with the square root of 13. So my value of x is 4 square roots of 13. All right, the next example that I have here is solving for x once again. But you'll notice that x now is one of your legs and not the hypotenuse. Oftentimes I'm going to see people write this out as 4 squared plus 16 squared equals x squared. X is not your hypotenuse in this case, so we need to be very careful of that. What is our hypotenuse is the 16. I can set this up. I can go ahead and set this up as x squared plus 4 squared is equal to 16 squared. Now that will work for us. X squared is x squared, 4 squared is 16, and 6 squared is 256. So solving for x, I would subtract the 16 from both sides, and that would end up giving me x squared is equal to 240. And now what I want to do here is try and simplify this out. And well, first of all, I got to take that square root of both sides. So x is equal to the square root of 240. I can simplify that square root. We can break this up into the square root of 16 and the square root of 15, which then would end up giving me 4 square roots of 15. 4 square roots of 15 cannot be simplified any further. So when you're working with the Pythagorean theorem, just be sure that you are always taking those two legs of A and B, and your hypotenuse is C. It's very important to understand that your hypotenuse is always opposite of that 90-degree angle. Okay. Right now we're going to be looking at the converse of the Pythagorean theorem. Converse, remember that's when you take your two statements and you really flip them around when it's an if-then statement. So we had before that if ABC is a right triangle, then A squared plus B squared equals C squared. Here we are reversing that. So now it says that if A squared plus B squared equals C squared, then ABC is a right triangle. So what I have right here is I have 3 lengths of a triangle. And what we're trying to do here is to determine whether it is a right triangle or not. Now the fact that these are the 3 sides, and if it is a right triangle, the longest side would have to be your hypotenuse in this problem. That would leave the other 2 sides here to be your values of A and B. So if we want to check to see if this is a right triangle, we could plug it into our formula and take 7 squared plus 14 squared, and we'll see if we get 16 squared. So when we take 7 squared, so that's going to give us our 49. When we take 14 squared, we get 196. And when we take 16 squared, I get 256. 49 plus 196 gives you 245. 245 does not equal 256. Therefore, these 3 sides here would not fit under a right triangle. Okay, if we try 9, 40, and 41. 41 being your longest side, that would have to be your hypotenuse. So we would try taking 9 squared plus 40 squared and see if that equals 41 squared. So we've got 9 squared, so that's 81, plus 40 squared, which is 1,600, and 41 squared is 1,681. Well, 81 plus 1,600 is 1,681. So the fact that those two right there are equal to each other, that means that these 3 sides here are the 3 sides to a right triangle. Again, prior to this one, I had 245 does not equal 256. So 7, 4, and 16 would not fit the 3 sides of a right triangle. Lastly, I'd like to go over some Pythagorean triples and explaining what that is. Pythagorean triple, what that is it is a set of 3 non-zero whole numbers. So that's the important part here, is that it's whole numbers that satisfy the Pythagorean theorem of A, B, and A squared plus B squared equals C squared. Now, if I look at these 3 examples here, 2 of them could possibly be a Pythagorean triple. The third one right here is not an option because they are not whole numbers. Square root of 8, square root of 5, square root of 13, those right there are not whole numbers. However, 3, 4, 5 is. So if I want to check to see if it is a Pythagorean triple, 5 is the longest side. That would have to be our hypotenuse. So 3 squared plus 4 squared, checking to see if that equals 5 squared. 3 squared is 9. 4 squared is 16. Oops, I'm sorry. Okay, so 9 plus 16, and 5 squared is 25. 9 plus 16 is 25. So right here we have an example of a Pythagorean triple, 3, 4, and 5. 5, 12, and 13. If we take 5 squared plus 12 squared, and we're going to see if that equals 13 squared. 5 squared is 25. 12 squared is giving us 144. Should be a plus sign right there. And then 13 squared is 169. When I take 25 plus 144, we get 169. So that, again, is an example of a Pythagorean triple. Both of these right here are examples of Pythagorean triples. Now the last one we can rule out as a Pythagorean triple right away because it is not 3 whole numbers. However, I just want you guys to see that when we take things like this and we apply the square root or the Pythagorean theorem to it, so the square root of 8, when you square that, and then we take the square root of 5 and we square it, and then we take the square root of 13 and we square that. The square and the square root actually cancel each other out, so that would give me 8 plus 5 is equal to 13. Now 8 plus 5 does equal 13, so understand that right here, although this fits the sides of a right triangle, it is not considered a Pythagorean triple. All right, so we're all done reviewing what the Pythagorean theorem does. So you now have the rest of the time to work on your assignment, and I will see you guys all in class tomorrow.